Let's continue with the design. And now we are going to focus on the reinforcement and on data input and on results, of course. First of all, let's go to the data in the navigator. And let's select what we are going to check and how. The most important thing now is to select the proper exposure classes. For now, let's go for XC1 only. Yeah, only XC1 in data.
Can we find data?
Here in the navigator. Do you have it?
No.
No. So you need to recalculate the model. So the exposure classes, please turn off these deflections because we are not going to dive into the nonlinear deflections because it's 4 hours to really understand it. And that's it. So in data here, do not calculate deflections, and the exposure classes will be XC1 only. Now we can continue, or we can proceed to reinforcement. This is the reinforcement, the passive one. This is not prestressing, the prestress tendon. This is the reinforcement rebars only. So by default, we have only one cross section for the whole beam, but I'm going to define some zones for different cross sections for different reinforcement layouts. In the top ribbon, click on zone templates, and we will select this one, the second last one. There will be A, B, C, B, A zones for reinforcement. In the top ribbon, and click on OK. So your model should look like this right now. But these zones are empty, and we need to input some reinforcement into it. Again, I will show you how to input reinforcement, longitudinal bars, and stirrups. And after that, we will import all of the cross sections already reinforced, because I don't want to spend time with it. So you can select, you can click on, for example, CC section in the scene here, and the reinforcement editor will be opened. And let's try inputting. It doesn't work well for this screen. No. Okay, we'll see. So let's go, for example, for longitudinal reinforcement. We can select, for example, new or on all edges, or maybe it will be better to use these templates just to show you that they are there. So click on the first template and input whatever you want, because as I've said, we are going to import them, all of them. So you can click on OK, and let's leave it as it is. And now you can see that you have these longitudinal bars. You can hover or switch them, change the diameter or the number. You can click on it in the scene if you need. Then there are stirrups, where you can again define the stirrups, the distance between the stirrups, what they will be used for, material, and the diameter of the stirrup. Yeah. If you want to learn it, the best way is just to try to reinforce your own cross section and try to have what you have in your project, basically. But now I will try to turn it off. it will be problem because let's do it like that. It doesn't work. Okay, fine. No, the resolution is the problem because I can't go away from this. That's bad. Work. Huh. Stupid Windows. I'm stuck, basically. Okay, I will shut it down. Do you have any idea how to go from second to stuck? And I don't want to lose the file. Oh, you are the best. You are the best. Thanks. He is the best. Yes. Okay. So what we are going to do, we are going to import the reinforcement. So again, in the top ribbon, there is the import button. You can click on it and select import reinforcement. Yes, I want to rewrite my reinforcement. And now I have CC section, so reinforcement for CC, and click on OK, open, and OK. And again, select or click on BB section. Reinforcement editor will be opened. You can click import, import reinforcement, and select reinforcement BB text file. Open and click on OK. And the last one is AA. Again, select it, for example, in the scene or in the graphical output. Click on it. Import in the top ribbon. And reinforcement AA. Open and click OK. So it should look like that. And this is it. This is the complete input. You can open the file and you will have probably the same as me or the very similar file as I have. I'm not sure if I did it like 100% the same. So if you are stuck or if you don't have it, you can open the file which was downloaded with the import files. It's complete design, and we will dive into the results. So are you ready? Yes, do you have it? Any problem? No? Okay. So let's click on results in the navigator. If you don't have results, you need to first calculate it in the top ribbon. There is a button calculate. Yeah. Before the calculation, where it is? You are probably here, somewhere here, and there is a button calculate in the top ribbon. You need to first recalculate the model, and then you can go to the results. And if you click on it, the cross-sectional check will be done. And as you can see, everything is okay, green, no problem. If not, you don't have the same model as me. But as I've said, you can open the model from the folder that was that you downloaded. But now we have only one cross section to be checked. Later on, we will add another one, but let's stay with this one in the middle of the span to see what's going on here. Now, I was speaking about RCS application and about the interconnection between Beam and RCS. Now we are going to send all of the data to RCS and do the code checks itself. So it is here in the top ribbon. The button is called detailed. It means like detailed results. If you click on it, the RCS application will be opened. This is it. You can see that we have only one section in the middle of the span and few extremes. These extremes are from the combinations, and these are the extreme combinations for the section. You can see that there is a transfer of prestressing stage and end of working life. You may ask why there are not others. It's basically because they are unchecked in construction stages in Beam. Yeah, I will show you. If I go to the construction stages in Beam, you can see that there is the column check, and you can select what you want to check, what you want to really calculate. And we have only this one and this one to have it simpler. Yeah. So again, I'm going to results and to RCS application, and I'm going to calculate the cross-sectional checks again by hitting the calculate button. Again, you can see that everything is okay. Results are satisfactory, no problem. So let's select, for example, the third extreme. And let's go to results in the navigator. And in data window, you can see all of the checks that are turned on that we want to go through and we want to have it. So now let's go to the capacity. This is the interaction diagram, which will show you where are you for this particular extreme. This is not the governing one. You can see that there is only 42%. So let's find the governing one, which will be not that one, or maybe this one. You can go through it, find your results, etc. But now what I want to show you is the stage of transfer of prestressing. It means just after the release of tendons or of strands. This is the first extreme. You can select it in the navigator. And let's go to crack quiz. And we are going to calculate cracks, if there are any. Yeah. This is the very beginning of life of the beam, just after prestressing, and we can see that there are no cracks. The stress of the concrete is 0.8 plus 0.8. And the top tendons are in compression zone. It seems that it's fine, no problem, no cracks. Let's go to stress limitation. Again, no problem in the stage of transfer of prestressing. -10 and 0.7 in tension for characteristic combination. Again, no problem. Let's go back to cracks. And let's go to the end of design working life. the first extreme again without any problem, and the second one, hey, we have some cracks here. You can see that some concrete is excluded in tension for crack calculation, and we have the value of this crack. And I have a question for you. Do you know how to calculate crack width for pre-stressed beam? Who knows? Like that. That's what I want to show you. You don't need to always remember all equations and all code. You just need to know how to do it efficiently. For example, using such software. Yeah. But on the other hand, you always need to be careful to input everything correctly. You need to check it twice before you say, hey, this is okay with crack widths. Yeah. I think there is a question. There is a question, a very interesting one from the online participant, if they are allowed cracks or not. They are allowed because we have only XC1 exposure class. Later on, I will increase the exposure class to XC2, and you will see that everything is wrong because the cracks are not allowed for higher exposure classes. So, crack width calculation, stress limitation, we have it. And okay, let's do it. Let's turn off the RCS application and back to the data. And let's increase the exposure classes. So what we can do, for example, XF1 and XC2. This is still nothing special. This is not a chemistry building or something like that. And let's go back to results. And you can see that's crack width 1000%, completely wrong. We can't do it like that. Why? Okay. In detail, in RCS application, calculate. Everything is wrong. So the first extreme, crack width, wrong, because we don't fulfill the decompression check, which is needed according to Eurocode. Again, do you know what is decompression check? No, you have the software for it. Okay, you need to know what is it, but you don't need to know how it must be calculated by hand. And this is the same for other extremes. If I go here, it was okay for the exposure classes XC1, but as you can see, it's really not okay for the exposure class XC2 and XF1. At the beginning, I've mentioned that you will have like very serious problems, more serious that taking care about precisely defining of relaxation at the beginning of the life of the beam. These are very important. Yeah? Someone will tell you, hey, but I need this kind of exposure classes, and your design is completely wrong. Yeah? To repair it, it's not only like cosmetic thing. You really need to add some attendance. You really need to, for example, increase concrete grade, etc. So you need to do it again from the beginning. So it's not about playing with small numbers. It's about redefining the whole beam if you have different exposure class because of the decompression check, which was not needed for XC1. But anyway, okay, let's go back to data and change it back to the only XC1 exposure class. Exposure class. And let's go to reinforcement. And let's take a look at shear. Yeah, you have calculated the shear in your lessons, I suppose. And for shear, I'm going to define another section for my check. It will be here, check position. So I'm going to add another one, section 2, and the distance will be 1.60 what? 67. I mean 69. Just at the beginning of the zone BB. Yeah. You know, in AA, we have the strongest shear reinforcement. In BB, it's a little bit lower, and in CC is the lowest shear reinforcement. Okay, we have section 2, and let's add another one, section 3, which will be here. And it's what? It's 2.5. Oh, no, it's point. I can't calculate 3.4. 3.4, sorry. So, and it will be 3.4. Yes. So we have 2 sections, and we are going to use them for the check of shear. And so let's take a look at it. We can go again to results. Everything is okay. Fine. Go to detailed. Calculate it. Go to results. For example, for sorry. So in sections, you have now 3 sections here in the RCS, and we will select the section 2, which is the section which is closest to the support. Are you still with me, or should I go around and are you with me? Yes. Yeah, okay. So this is the section 2 for the shear check. We just need to select the governing extreme, which would be that one. You can see here that there is the value of utilization for all of the checks. So for shear, we have 97% right now. If I switch the extreme, this one is again 97%, and this one is 61. But so the governing will be this one. You can go to the results, to shear. You can see again, the shear is calculated automatically. You have all intermediate results here. So if you go to the calculation of shear to the Eurocode, you can go number by number, equation by equation, and check your numbers with IDEA or with the RCS software. Oh, he's back. Fine. Where were you, Easy? Sorry. Sorry, Lukáš. Easy is mine, another colleague. So in case you have you need any help, Lukáš is here, so just raise your hand. So where if you want to do a cross-sectional check for shear, you can go equation by equation, and all intermediate results you will have them here. This is it. So we went through the, let's say, I showed you exposure classes, what are the problems with exposure classes. I show you how to add sections and how to deal with the shear, for example. What is ahead of us? I would like to dive a little bit into the code settings and show you where you can find all of the settings, and not for changing them, but for have the information. Okay, this particular number or coefficient or whatever is according to this part of your code, yeah, because it is there written, and you can orient in the Eurocode through the application very quickly. Then I'm going to show you how to work with combinations, and we are going to touch the torsion. Did you do the torsion in your lessons? How to check it? Yeah, so you know what is thin wallet section, this kind of T effective, and it's around the cross section. So I will show you that, and I will also show you the interaction between shear, torsion, and bending moment. This is the hardest part of the cross-sectional check. So we will finish with this interaction. So now let's take a look at the code setting. I'm going to go back to the RCS again, and here is the code setting. Why I want to talk about it is that, you know, there is the basic Eurocode, and then there are national annexes. We have about 9 annexes implemented. Unfortunately, there is no Romanian annex. But what you can do, you can like redefine basically the whole Eurocode in the application and save it by your annex. And then again, of course, load it. So let's go to the code settings, and I'm speaking about it because there are chapters. These chapters are taken from the Eurocode 2, from the design for concrete structures. And for example, we were speaking about about shear. So if you want to redefine what is defined in the code for shear, or if you want to very quickly find, for example, where you can find this alpha CW coefficient for shear in the Eurocode, it's always written here in the tooltip. Does it work? Yeah, it's working. We were speaking about decompression. Yeah, there was something wrong with our beam when we had the exposure class. So we can go to the chapter 7, and there is the definition of decompression. You can find where it is in the Eurocode, the equation. Do you know what is decompression? What does it mean? This is kind of magical word. No? Well, I will explain it. The decompression is it's the thing. It's the very complicated stuff for engineers, because if it is something wrong with the design, is the decompression. I mean, with the design of pre-stressed member, is the decompression. Because for 95% of exposure classes, you need to fulfill this decompression, and it means that the tendons must be in a compression zone, and it's a little bit harder because they must be in compression zone. What?
Your results are passing, all the results, right?
Yes, right now you're not. Why? Many reasons for that.
There is some technical class issue with maybe it is correct. Yes.
So the decompression. All of the tendons must be in the compression zone. And it must be 25 millimeters in the compression zone. Just remember it because this is like the most critical check. I think this is one of the most critical checks of the pre-stressed beams. Is decompression. You can also define, for example, the correct ways if you want to check the compression or not, for which exposure classes, etc., etc. So now it was the talking part, and let's model again a few things. So, well, the question for you is how we can input or how we can have the torsion in our beam. Do you have any idea how to do that? Eccentric load, yes, that's right, that's correct. That's what I wanted to hear. So let's go to the load cases.
Check if the project is set on 3D beam and not into the.
Yeah, that's good. That's good. Before we do that, that was a good idea. Go to project data and just check if the project is set as a 3D beam here. Straight or polygonal beam loaded in 3D. If you have 2D, just switch it to 3D. It cannot be switched back, but from 2D, it can be switched to 3D here in data. Is there anyone who needs to check, who needs to switch it to 3D? Or everyone has the 3D? Yes, everyone in 3D, that's cool. So let's go to the load cases, and I will show you how it works. So let's click on the plus button to add another load case. Let's name it as Q torsion. Sorry. The load group will be, first we need to switch the type to variable. And the load group will be LG2 exclusive. Do you have it? Oh, no. I see. Q torsion, LG2 exclusive variable load. So we will add some torsion. And Now I would like to explain what these things means, like these load groups, types, etc. So basically we have two types of load groups, permanent and variable. Permanent load groups are always added together. That's the simple thing. And the permanent load groups can be like connected with construction stages. You know that if I add some load, well, okay, let's do it in a different way. What will happen with deflection? If I add a load at the beginning of working life, there will be some immediate deflection. Yes, that's right. What will happen at the end of the working life? Will it be the same? Will it be greater or smaller, the deflection? What do you think? Greater or smaller? Greater. So who thinks that it will be greater? And who thinks that it will be smaller? No one. That's good. That's right. And do you know why? Why it will be greater? What is the phenomenon? Creep. Yes, of course. Thank you. Yeah. So that's the reason why we need to do this time-dependent analysis, to have the proper deflection, for example, because of the creep and shrinkage, of course. So permanent loads are very simple. You can just define these partial load factors, but they are according to Eurocode by default, so you don't need to care about them, but it can be redefined. What is more interesting are these variable loads. You can have two types of them, standard and exclusive. And again, these coefficients are according to the code. It can be defined according to the type of the structure. They are different for bridges. They are different from, I don't know, residential buildings, for offices and stuff like that. There are tables in the Eurocode, so you need to find what kind of building or what kind of bridge you have and redefine them, because the combinations are created based on these coefficients, of course. You know, there is 6.10 combination, you know it, for ultimate state from Eurocode, 6.A, B, etc. Have you heard about it? This is new for you. Okay, so we will dive into it a little bit more. But anyway, I will explain what does it mean, the exclusive and standard one. Yeah, I have a slide for that. Give me a second. So the explanation of variable loads. So let's assume that we have what? We have three load cases, sorry, LC1, LC2, and LC3. Yeah. I said that my LC1 load case is standard load case type, here, the gray one, and LC2 and LC3 are exclusive. Then I want to add them together. What will happen? Let's say that the value for, it doesn't matter what, like value of bending moment of LC1 is 5, the value for LC2 is 6, and value for LC3 is 7. So if I add them together, LC1 plus LC2 plus LC3, the result for the envelope maximum will be 12, because it's 5 plus maximum value from these two. This is why they are exclusive. Only the maximum or minimum load case is taken into account. And of course, for minimum, it would be 5 plus 6, because the 6 is minimum for this case. And we are going to use it right now, like that, for distortion. So let's go to the load cases. We have LG2 exclusive, and variable loads. We are going to input uniform loads, select Q torsion, the new load case we have just created. Rychlejší přestávky, tak já to dám do U a kousek a pak dám diskuzi.
Takže končíš kdy?
Co?
Teďka budeš končit kdy?
Tak o půl a kousek a pak dáme ještě diskuzi.
Jo.
A
Takže o půl ti mám říct.
já si to hlídám. So select the Q torsion and add the uniform load. So the value would be, it can be minus 30. And what we are going to do, we are going to add the eccentricity in the Y direction to have some torsion in our beam. So I'm going to switch to the axonometrical view in the top ribbon to see it. I will rotate it a little bit, like that. And I'm going to input the eccentricity in Y direction, let's say 0.15 at the end and 0.15 at the beginning. Yes. And again, yeah, Q torsion is exclusive with Q. It means that only the critical one for the particular effect will be taken into account with other load cases. So let's calculate it. And let's go to results. Again, everything is fine, okay. And we can go to detailed. Hey, yeah, sorry, I forgot one thing. I forgot to modify, sorry, I forgot to modify combinations because we have created the Q torsion load case, but we haven't added this load case to the combination. So we can do it here in combinations, and that's why I am doing it. And click on the edit button. And here you can see all of the combinations that were created automatically. Do you have this tables from edit button? Yeah, okay, fine. So you can see them, all of them, and you can see that for example, the stage of transfer of prestressing, we have ultimate fundamental characteristic. This C means serviceability limit state characteristic. Yeah, serviceability limit state, frequent, quasi-permanent, ultimate limit state, fundamental. Yeah. There is fundamental and accidental. Accidental is, for example, if you crash by car into the column or something like that. And we have for all of these construction stages. So I have the question for you, where we need to add our load case Q torsion. For what construction stage or stages? It is the variable load. If you imagine bridge, it can be the car which is going like not exactly above the beam, just a little bit, like in the eccentricity, where we need to input this Q torsion load case to what construction stages. Just try it.
Final support or
Final, yes. No, final support's not, because final supports is the state if you put your beam to the final supports, and there is only the beam. There is no topping. There is no deck above it. There is nothing. So not that one. But yes, this one, because this is actually the start of the life process, and yes. So I will add this Q torsion into the all combinations for superimposed dead load and for end of design working life. So we can select them using the using shift.
why do you have this combination here?
I hate you. Give me a second. Why do I have this characteristic sum? I don't know actually. He will tell us, but let's continue. And let's move the load case to the combination by clicking on it and use this button with arrow to the combination. And you can see if I select, for example, superimposed load, ultimate limit state, fundamental, I have here this Q torsion. And Lukáš will explain us why do we have here these combinations. I know, what is it? I see. At the beginning, we started in the wizard, and there was the button. Do you want to create special combination only for prestressing and rheological effects? And we picked that yes, we want to do that. And so this is only the auxiliary combinations, and you can see that there are rheological effects from all of the construction stages, plus effects from pretensioning. So you can check if you have this Q torsion in all combinations in these two construction stages and click on OK. We need to recalculate it. And after that, we can take a look at the torsion and discuss this interaction of internal forces. Again, go to results and to detailed check. And we can see here, I'm going to visit results and the interaction. So I will have another questions and I need to stand because so what do you mean? Where is the problem? Do you have any idea? So we edit torsion, and now there is the problem. The section is the first section at the beginning of the beam, and we have the problem. Something is unsatisfactory. 195%. Where is the problem? What is caused? What is the reason for the problem? Yes, of course. The problem is that we added the torsion and it caused the unsatisfactory check. And we can find here that the problem is with interaction of shear and torsion for shear reinforcement. And one of the branches is not satisfactory right now. It can be even calculated because it's really a bad result. What we can do with it? You have calculated the shear in your practice. So do you have any idea what can be done with the shear?
Yeah.
Yes. Yes. Good idea. Good idea. But what if it's what if this modification is too expensive? I don't have money for more steel, and what can I do with the unsatisfactory shear and torsion check? This is the hard question, actually. We can try our professors if they are still not sleeping. What we can do with it? I don't have money for additional steel, but I want to have it satisfactory. And I know that the problem is
in my opinion,
yes, go for it.
You have to change the cross section.
You don't have to change your cross section still. You don't have money for it. You don't have money for reinforcement. You don't have money for concrete, but still the shear and torsion is unsatisfactory. And I'm your boss. I'm pushing you just to make it, satisfactory. What can we do, Lukáš, with it? Yes, of course. He's a clever man. In Eurocode, there is one angle. It's theta angle. Do you remember? From 45 to 21.8 or something like that. Yeah, and it's up to engineer to select the angle. Yeah. Okay. Okay, the angle is here. So let's modify it. What do you mean? What angle can we use? What will be the satisfactory angle? Lower, but what number?
What it's going to be.
Correct. Current is 45. We have it here in the top ribbon. 45 is current angle, and it's unsatisfactory, and it's unsatisfactory. 20? 20. Let's go for the minimum angle. It's approximately 22. Hey, it works. Let's calculate all of the sections. And it works. Do you know how it works? Do you know the Stratton-Die method, or the Stratton-Die, how it calls? That it's similar to the Stratton-Die, and we have the concrete strat. And if you lower it, if you lower the angle, you move the concrete strat, the angle is lower. The shear reinforcement is like efficiently used, but the concrete strat is more loaded. But we have high strength concrete, almost high strength concrete, so we don't have problem with concrete strat. We have problem with shear reinforcement. So if you decrease this angle, you can do this. You can do this according to your code. You can save money just by changing this angle. Sometimes it can happen that you have weak concrete and problem with reinforcement. So you need to find the proper angle. It works. The principle is that the structure will have always the minimum energy. Yeah? So the angle will be always like the the best one. So it means that if you are able to find any angle in the range from 45 to 22, if you are able to find any angle, the structure will have slightly better angle because of the minimum of the energy. So that's the reason why you can choose this angle. So if you find it, you can be sure that the structure will survive. So this was it. Well, I think I'm not go for I don't want to go further because you know it's 4:30 right now. We should finish at 5. We started a little bit earlier after the break. So let's leave it for now, this example. I showed you everything what I wanted to show you in the application. Now it's up to you to spend some time with it. Yeah, you to really understand, you need to take your example and you need to design it step by step and compare your values and compare the values from the software. If there will be any difference, you need to find the reason. Why these two numbers are so different? Because I did this input incorrectly. That's you need to do right now. And I really recommend to play with such things like this angle, play with shear, with torsion. Take a look how it is calculated in the application. I will show you. Yeah, I forgot to show you this thin wallet section. So let's go back to the RCS application and let's check this torsion. Yeah, I suppose that you know this one. Again, there is the question: who knows how to calculate this T effective value? Who remember how to calculate it? You did it, I know, a few weeks ago. Am I right? You remember it? That's why you have the application. You have this T effective value, and this is the result. And few last words about the interaction. What is the problem in it? Why it is so complicated? There are a lot of tables that needs to be understood, but where is the problem? In shear and torsion, you need to check basically two things: vertical direction and the longitudinal direction, let's say. So you need to check what? You need to check shear reinforcement or combination of shear and torsion, because the behavior is very similar. And you need to check longitudinal reinforcement as well, because it is like loaded by bending. It's very like understandable, I think. For example, if you are in the middle of the span, these bars are loaded by bending or near the middle. If you are near the middle, there is also a shear that adds some longitudinal tensional force for that. And that's why we have this kind of checks here that will also tell you this one, the stress in the longitudinal reinforcement, there is the check, etc., etc. So that was it.
How can you get the longitudinal force from here?
If you want to know only the force, just input internal forces without any other force, only with the shear. And here you will see the force. Just to try it.
Okay, thank you.
Yeah, no problem. Okay, let's finish with the frontal speaking, and let's do the questions. So if you have any questions, don't hesitate to ask. We can discuss everything. There are also online participants if they are still here. You can write a question if you want, or if you want to see anything in the application, some results, don't hesitate to write here to the chat. I'm looking at it.
Thank you, Thomas, for this detailed presentation. I will continue in Romanian. Mulțumim tuturor participanților, atât studenților cât și inginerilor prezenți online. Și dacă nu sunt întrebări, noi o să revenim cât mai curând, cât mai rapid posibil cu înregistrările și așteptăm întrebări, discuții tehnice pe info@reflexsoftware.eu. Vă mulțumim încă o dată și vă dorim o dupămasă plăcută. La revedere!